There are many problems that we can't really solve by land-based drilling. For instance, where we went this time in the Arctic Ocean, there's no real way to figure out the history of the Arctic Ocean without being right in the ocean, and that's the Arctic Ocean is quite important for understanding the entire global climate system. The other thing too is we get these very continuous records in the ocean as a whole. So on land, most of our records are very discontinuous, and so if you want to understand how things are evolving through time, you've got to get like a long tape recorder, and that's essentially what we're doing by drilling in the ocean. You can't do that in most places on land.
We've seen over the last, let's say, 500,000 years, enormous climate changes. Sea level was in the last glacial about 100 meters lower than it is today, so who cares about another 5 centimeters rise? The difference is now that we live in a world which is having about 6 billion people. So every small change can have a huge impact.
If the world is really warming up like everybody is predicting, then it will happen in the high latitudes. And that is a serious matter. The high latitudes get too warm and the sea level will rise. So by studying these events in the past, we can learn about these positive feedbacks in the climate system. We know they have happened, but we have to document them by drilling these events.
We might figure out, what are the sort of boundary conditions and changes that might be expected over the next couple of hundred years, and then sort of plan ahead. It would sure be nice to know what would happen, let's say 50 years down the road, 100 years, pick whatever time you want, and actually build things and construct a society with that in mind, rather than just sort of wandering around blindly, sort of wreaking havoc on the climate system and saying, oh, gee whiz, look what happened.
The climate models are just a reflection of our knowledge. And it's not that they perform on themselves. They are being made by people. And the people who make those climate models, they need to be fed with information on how we think the ocean works. And we're still learning new things about the ocean. So we can put all those new ideas, we can test it, and we can put it into climate models to improve climate prediction.
The oceanographic community is a community that's very used to working together, because most of the people in oceanography have had to team up with someone to get their work done. You've got to work with a geophysicist to get the data you need to select your site. So there's a culture that has evolved in oceanography. In addition to that, the ocean drilling program and the previous deep sea drilling project were programs that were started by the United States and led by the United States. And the culture there is one of collaboration. And that has permeated across, I think, this is my view, across almost the international scientific community. Now we're seeing a leadership from Japan and Europe that I think will alter the culture a little bit, probably for the better, but it will be still a very collaborative effort.
It's a real plus to have this international crew of scientists, because the expertise that you need, if it all had to come out of, say, the US or the UK or Germany, we just couldn't put together a crew of this quality.
Fantastic with this sort of drilling is the international cooperation. You can't do this on your own, you have to work in teams, and we are friends forever.